Hello, I am Professor Mangesh Joshi, working at Sri Ram Bar College of Engineering and Management. Today, I welcome you to another video on the course Data Science. So, in this video, we will cover the histograms and bar chart used in data exploration phase. So, you people are already aware regarding what are histograms. So, a frequency distribution shows how often each different value in a set of data occurs. A histogram is the most commonly used graph to show frequency distributions. It looks very much like a bar chart, but there are important differences between them. When to use histogram? So histograms are used when the data is numerical, and the bar charts are used when the data is categorical. For example, you have the data of say age. You can plot the histograms. But suppose you are having the data of say gender, so you will be plotting the bar chart or bar graph. You want to see the shape of data distribution, especially when determining whether the output of the process is distributed approximately normally or not. Histograms are used when analyzing whether a process can meet the customer's requirements. Then histograms are used when analyzing what the output from the supplier's process look like. So in different scenarios, you can use the histograms when the data is numerical, right? So how to plot histograms in Python? Now suppose we will take a real life example that you are monitoring sugar levels of each patient coming into your hospital. So you have the data set showing the patient number arrived at your hospital, their corresponding sugar levels and their gender. Okay. So if you want to plot a bar chart, you will use this data. This is a categorical data, male, female. But if you want to plot a histogram, you will be requiring this data, which is a numerical data. So you can see here all the values are numerical. So the normal ranges are given, that is, if the range is between 80 to 100, the sugar level is normal. If the level is between 100 to 125, you are a pre-diabetic case. Then if the level is above 125, you are a diabetic patient. So if you want to answer 3 questions from the data set, that how many patients are normal, how many of them are diabetic, pre-diabetic, and how many of them are diabetic. So in suppose the data of patients of 1000 patients you are having, it is very difficult to see by just looking at the numbers, right? So in this case, we can plot histograms to answer these 3 questions very quickly. So how to plot a histogram in Python? So I have imported 3 libraries which usually require, that is import numpy as np, import pandas as pd, and import matplotlib.pyplot as plt. So suppose you are having a list of say sugar data, okay, and you are having the sugar levels of each patient coming to your hospital. The second variable is bin, is a list. So this bin refers to the ranges of intervals you want in your histogram. That is, for example, you want first ranges between 80 to 100. So your histogram will start, the first is 80 and then to 100, right? So I have given first level as 80, second as 100. Next you want 100 to 125. So I have given next as 125. Okay, so you are having 100 to 125. And third range, that is a case of diabetic patient, that is greater than 125, right? So that's why I have used a function that is np.max to calculate the largest value in the dataset. So you can observe that the largest value in the dataset is 156. So it will calculate up to 156. You can see that in this histogram, first interval is from 80 to 100, right? This is the first interval. Second is from 100 to 125, right? This is the second interval. And the third interval is 125 and greater. So since the largest value or maximum value is 156, you can see the bar up to 156 only, right? This is on the x-axis. If you look at the y-axis, you will get the frequencies or count. Okay, so this is the second variable, that is bin. Now using the function hist, you can plot the histogram, that is by plt.hist sugar data, comma, bin, comma, r width is the relative width. If this r width you set to 1, this all bars will be joined. You will not see the gap between two intervals. Okay, so this will be joined. If you set r width as 1. So just to separate out these three intervals, I have used r width as 0.95. Okay. Now next is, if you want to label the histogram, you can use plt.xlabel, sugar level. So you can see sugar level is here, Y label over here, and the title of this histogram on the top, right? And finally you have to do plt.show. So you will see the histogram. Now by just looking at the histogram, you can answer these questions. That is, how many patients are normal? So normal range is between 80 to 100. So you can see that there are 7 patients in the normal category. How many of them are pre-diabetic? So pre-diabetic range is 100 to 125. You can see that there are 8 patients in the second category. And third, how many are diabetic? So there are total 5 diabetic students, you can see over here. So in the third category there are 5 students, 5 patients, right? Now this histogram can take different types of shape, and there is different meaning associated with the type of shape obtained in the histogram. So first, common type is normal distribution. So normal distribution is a common pattern, is a bell-shaped curve known as normal distribution, right? So in a normal or typical distribution, points are likely to occur on one side of the average as on the other, right? So if this is the average, suppose this data shows the height of students in a class. So suppose this x bar represents the average height, which is, say, let us say 5.2 centimeters. So you may have very few people having height 6 centimeters, or not 6 centimeters, it's 5.6 feet. Okay, and you will have very few people having height as less, let's say, 4 feet. Okay, so in this way, this normal distribution can form using this histogram. A second common shape which you may observe, that is a skewed distribution, right? When this distribution may be left skewed as well as right skewed. Okay. So skew distribution is asymmetrical because a natural limit prevents outcome on one side. The distribution's peak is off-centered towards the limit and the tail stretches away from it. For example, a distribution of analysis of a very pure product would be skewed because the product cannot be more than 100% pure. Right? So you can see that the mean of this is shifted on the right side. Okay, and in this case the mean is shifted on the left side. Okay, so this is left skewed and right skewed distribution. The next type is double picked or bimodal. So you have already seen what is mode. So the most repeating value is the mode. Most repeating means with higher frequency, right? So bimodal distribution looks like the back of a two-humped camel. The outcomes of the two processes with different distributions are combined in one set of data. For example, a distribution of production data from a two-shift operation might be bimodal if each shift produces a different distribution of results. Stratification often reveals this problem, right? So this is a bimodal distribution. Now Plato or multimodal distribution. Similar to bimodal distribution, if the distribution is having multiple modes, so it will be called as multimodal distribution. So several processes with normal distributions are combined because there are many peaks close together. The top of the distribution resembles a plateau. So if the sugar level case, if we take sugar level on the x-axis and count on the y-axis, so this is mode 1, this is the mode 2, this is mode 3, and this may be considered as mode 4. So this type of arrangement can be called as multimodal distribution. Now age peak distribution. The age peak distribution looks like the normal distribution except that it has a large peak at one tail. You can see in the example that it is having a large peak at one end. Usually this is caused by a faulty construction of the histogram, with data lumped together into group labeled as greater than or less than. So in the example of sugar level, we have seen that the sugar level greater than 125 are labeled as diabetic, right? So in such cases, you may get such type of peak at one of the tails, either on the left side or the right side. The next pattern observed in the histogram is truncated or hard cut distribution. The truncated distribution looks like a normal distribution with its tails cut off. So you have seen that a normal distribution is like this, right? This is representing your mean or average. So if the tails are cut, the distribution in between this is termed as truncated or hard cut distribution. So the supplier might be producing a normal distribution of material, and then depending on the inspection to separate what is within specification limit from what is out of specification limit. So in this case, suppose a supplier is manufacturing a certain set of items and is only delivering this portion of the products. So, and if your vendor plots the distribution of the received items, then he will get the truncated or hard cut distribution. The next is dog food distribution. The dog food distribution is missing something results near the average. You can see that there is no value in between this. The product falls into two clusters, one near the upper specification limit and one near the lower specification limit. So for example, in the previous case, we have cut this portion and the remaining products which are in the specification limit we have delivered to our customer, right? So he may get such type of items and it may create a problem for him, right? This is the dog food distribution. The next type of tool is bar chart. So a bar chart or a bar graph is a chart that presents the categorical data with rectangular bars with heights or lengths proportional to the values that they represent. The bars can be plotted vertically or horizontally. So suppose we import numpy as np, import pandas as pd, import matplotlib.python as plt. We have one list that is representing the language and we have second list corresponding to the numbers. We have to match the count of variables in this language list and the number list. If there are 5 items in this language, there must be 5 items in this number, right? You can use any variables over here. You can use the bar function to plot the bar chart, language comma number. So you can see that the bar graph or bar chart has been plotted here. Then again, similar to your histogram, you can give the labels to your x-axis, y-axis, and then you can show. I hope you have understood the histogram, the various patterns of the histogram, and as well as the bar chart. Thank you for watching the video. For more videos, keep watching the channel Untwisted Learning and do not forget to subscribe. Thank you and have a nice day.